Hello, dear student, and I'm talking about physics. And the chapter is electromagnetic induction. इलेक्ट्रोमैग्नेटिक इंडक्शन प्यार से लोग बोल देते हैं EMI इलेक्ट्रोमैग्नेटिक इंडक्शन. इंडक्शन व्हाट इज इंडक्शन? बेसिकली इंडक्शन को कहते हैं दूर से प्रभावित हो जाना, दूर से इफेक्ट में आ जाना, यानी विदाउट फिजिकल टचिंग. When the fields are interacting, and the two fields are interacting, that we can say that effect of induction. But the field should be of same property. We saw electric fields and magnetic fields. That is, here we can say that the magnetic and electric effect are combined. Electric and magnetic effect are combining that electromagnetism. Another name is electromagnetism, is a branch of physics. When magnetic flux change through any conductor, by the magnetic flux, what is magnetic flux? That's simply number of magnetic field lines counted normal to the surface. That is very simple definition. Suppose this is the surface and this perpendicular is the called surface area vector, and here is the magnetic field lines in this direction, a magnetic field. Then this angle is theta, then we can say that E cos theta. But the component of area in the direction will be A cos theta. That we can say that the flux B dot A and next B A cos theta. The angle between area vector and magnetic field vector, not a plane, because this is the plane of area. The angle not is plane. Area vector is perpendicular to the plane. If we consider the area of this board here, then what is the direction of the area? Outward from the board, perpendicularly outward from the board, inside inwards to the board, the direction of area vector. What is the angle in area vector? Solid angle is used in this. We not set the area of circle, the concept is basic. We not pi r square. What is this pi? This is angle in star radian. Some people think that this is radian. No, this is not radian. This is star radian. This is solid angle. Okay, be careful. And here that if we talk about the circumference 2 pi r or any circle of radius r, this is the angle 2 pi. This is radian. So the difference of the area angle and the linear angle. This is angle used to measure the length of arc, and this is to visualize the area. If we want to visualize the area of this, that we have to open our eye perpendicularly of this. This is the solid angle. If you are seeing this one board, then you can consider what is this angle, solid angle. The conical solid angle. Here the conical solid angle. That is the pi r squared. What is pi? Solid angle. Okay. So the area vector is perpendicular to the plane of the area, it is transformed. And the magnetic field lines are defined as BA cos theta B dot A. The basic concept of electromagnetic induction. According to Faraday, the negative rate of change of magnetic flux. The negative rate of change of magnetic flux is equal to induced EMF in conductor. When the magnetic flux linked through the conductor. This is not a crucial definition. This is very simple definition. Negative rate of change of magnetic flux linked through a conductor is equal to induce EMF in conductor. And the other word may be across the conductor. Here we can say that across the conductor. And the simple, if we consider a conductor of this circular loop, conducting loop, and here we have a magnet of this type. This is the north pole, this south pole, and this magnetic is moving. The magnet is moving towards this or moving away from this. Then we can measure that an induced current in developed in this. Suppose we connect a meter here, that we have a reading in a meter that the induced current. What will be the direction of the current of this? Answer will be according after that. The Faraday's law, Lenz's law explain the direction. To explain the direction, we use Lenz's law. Because magnetic flux pass through any conductor, closed loop, yeah, or any conductor. Then the electrons, conducting electrons inside the conductor experience the Lorentz force and move in a particular direction according to force. But to avoid this force, they also react against this force. The change of magnetic flux through the conductor is opposed by the conductor because conducting electrons have inertia. So due to the reaction, there will be an induced current is developed. Okay, and the electron move in a particular direction to avoid the Lorentz force. And the concept is very simple. We know that Lorentz force Q V cross P. And we can say that if we do this, this will be developed to avoid the force zero. When you apply force to anything that is in particular situation, particular physical situation, particular equilibrium situation, then this thing will try to avoid this force and develop a reaction. So on the average of this force becoming zero, this electric field is developed. And this electric field develops E dr across the conductor, that is called dV. This is the induced EMF. It's a simple concept that we will explain further the phenomena, what is happening in this chapter in detail, what is the direction of EMF, direction of induced current, and how the mechanics and the mechanical effect is used in this chapter. Because this chapter has a mechanical advantage of the rotational motion, force, the moment of inertia, energy conservation, some conductor having mass, is rotating, moving, that is mechanical and electromagnetic energy also conserve or the competition level, the advanced level and other. So We will discuss further in next video. Thank you very much.